continue with the mesh analysis that we started last time. We said on the mesh analysis, if we have a circuit, we identify the number of mesh we have, like mesh 1 and mesh 2. Then we put, or we envisage, circulating current, either clockwise or counterclockwise, on these. Envisage or imagine, they are not real, okay? Circulating, and relate the actual current on the element with respect to these this mesh current. For instance, we relate I1 and it will be IA, the mesh current IA, and I2 will be IB, and I3, because it's going down, it's equal IA minus IB, okay? And then we will develop a method to find this mesh current, okay? Take an example like this one. This is, we have a 3 mesh, اللي هو mesh 1, okay? And then mesh 2 and mesh 3. And then we can go and find and put 3 circulating current. As I said, could be all clockwise, all counterclockwise, or a combination. Okay? These 3 circulating current, I can express any current on each mesh with respect to this mesh current. For instance, Faisal Khalid, can you turn off your... Yeah, okay. Thank you. خلاص, but that's it. I want you to put your microphone off. Okay, so we come over here. Suppose this is element A. This current going through an element A from bottom to top, this, it's in the same direction as the mesh current I1. So we said then that this current, I can express it as I1, okay? Same thing for element B. The current, this one, from left to right, it will be also I1. When we come to element C هنا, the current coming هنا down, هذا I1, but I2 is going up, okay? And since I want it to be down, so this one will equal then I1 minus I2, okay? And this one over here also, since the current I1 is coming circulating like this in this direction, and I3 coming on the other direction, the opposite direction, so this current is going to be equal to I1 minus I3, okay? And so on, okay, and so on. For I2, the same thing. طبعا الكرنت and I, well, no, just we wanted to see this direction, okay? Here it is. Here are the direction of the current, okay? The mesh current and the current through the element, okay? After we do that, we can write KVL on each mesh, okay? We write KVL in each mesh. That will give us 3 equations of a KVL equation in terms of the mesh current I1 and I2, and I will be able to solve them, okay? Let's look at an example. You know, with a like something like this. I have here a circuit with a 3 mesh, okay? Mesh 1, هنا, mesh 2, and mesh 3. First, this is the identification. You identify them. Similar on the nodal analysis, you identify essential node, okay? Now, I put 3 circulating mesh current on them. They are clockwise, okay? Next, I write KVL on each one. This is, you have to be careful when you write them. Let's explain them one by one. So we take mesh 1 over here. Since I am current circulating clockwise like this. So you flow with the current. You flow with the current. How the current move, you flow with it. Okay. So, طبعا here in the 10 volt, it's a voltage rise. But in the 4 ohm, this flow until you're coming in this direction, left to right. You are coming left to right, like this. So I want the current that going like this, and I want the voltage like this. حتى ما أضطر put negative sign. The current that is going on this direction هو المحصلة أو resultant between these two مش current، لأنه I1 is going like this و I3 is doing something like this. هذا I3 هنا. Okay. This is I3. So, the current that is going in this direction is going to be equal to I1 minus I3. I1 minus I3. Similarly, on the 6 ohm, okay, since you are going clockwise like this, you want the current that is down. حتى you can write the polarity هنا plus minus just 6 times this current. The current that is down is going to equal to I1 minus I2. Okay, I1 minus I2. So basically then what you will have this over here. This is the current, its direction, the element, and this is the polarity, and this is the voltage. Okay, as we agreed before, when we come to a current, when we flow with the current, when we come to a resistor, we make it a voltage drop. Why? حتى if you make it a voltage drop and you are assuming voltage drop is positive, positive when the KVL, the current that is entering over here with this polarity, I don't need to change the sign. But if you put it minus plus like this, you have to put a negative sign هنا in front of the 4. Okay, and we said we don't want to do that. You can, but you don't want to. We want to avoid it just in case you make a mistake when you add them. Okay, طيب. We do that, and then we write the KVL equation, and here is the KVL equation describing the KVL with respect to the mesh current I1, I2, and I3. I simplify it, and here it is, and that will be equation number 1. Now I go to mesh 2, and I do the same thing. طبعا I go clockwise, the same thing. Okay. And here, for instance, the same thing. The current is going to be in this direction, a resultant, and it will be I2 minus I3. And the voltage, we said we wanted voltage drop هنا. In order, so I can put this one 3 I2 minus I3. طبعا what will happen, this is the current that is on the element because you are going on this direction. Okay, now the voltages is going to be this. The voltages drop on this element resistor. Okay, and I just write KVL equation as shown over here. I simplify and I get this. Now I have 2 equations. I go do the same thing with the third mesh, exactly the same procedure, and I get the current through each element. Remember, now we are going on this direction like this. Okay, and then I write a voltage drop on them and write KVL and simplify. At the end, what I will have 3 equations, 3 unknown. I can put them in a matrix form and solve. For instance, if the question is find, for instance, ix مثلا, like this, ix. I can see that this ix is the same as this one, يعني ix is equal to I3. So all I have to do is solve for I3 only and say ix equal to I3. لو المطلوب for instance الكرنت في الاتجاه هذا up, I will say that this is I2, okay, I2 minus I1. And I will find I1 and I2 only. Okay, that's what I need. Okay. Let's go back again to our circuit that we explained before. As we said, we have 2 mesh, okay? And then we put a circulating current, mesh current, I and IB. And then I go and write KVL around. Okay, طبعا in mesh IA, هذا is coming up like this. So the current, this one is really IA, okay? And the voltage drop هنا هذا plus هذا minus is going to equal to R1 IA, okay? And this هنا I can write it down. طبعا هنا أبغاها voltage drop plus minus, معناها الكرنت I want it to be down over here, and this current over here is going to equal to IA minus IB. فهذا الفولتج is going to equal to R3 IA minus IB, okay? And then I write the KVL equation. طبعا take the V1 لأنها negative voltage rise to the other side, so positive. I simplify it and I get this. I apply the same thing on the mesh 2 and I get 2 equations to unknown. I will be able to solve for IA and IB. After I solve, I'll be able to find I1, I'll be able to find I2, and I'll be able to find I3 as we shown before. Okay?
Doctor?
Yes.
You said always to assume voltage drop when taking the KVL around the resistor, right?
Yeah, we said this minute.
The question will put the polarity for you. He will put like voltage rise instead, minus plus. What should I do?
Okay, okay. لنفرض اخذ الار 1 اللي هنا هذه بس عشان to make a space I'm going to draw it over here. هذا R2, اوكي. احنا قلنا احنا نبغاها لانك انت coming like this, you're coming like this, اوكي. فانا ابغاها بلس ماينس، صح؟ فانت الان تقول لا انا ابغاها انا ابغى what will happen لو حطينا هنا هذا ماينس وهذا بلس، صح؟
يس زي من السؤال معطيك كذا.
اي ماينس بلس احنا حنشوفها شوي بس ما since you ask it's okay. طيب الكرنت that is entering over here still هذا هو IA، صح؟
صحيح.
الان الكرنت IA entering، الان البولاريتي اللي انت حطيتها الماينس entering from the minus، صح ولا لا؟
Yes.
طيب if according to Ohm's law when the current enters from the minus, is it RI or minus RI?
Minus RI.
So it will be هنا minus R2 IA، صح ولا لا؟
صح.
نحط طيب هذا I A. طيب الآن هذا أوكي، هذا ما it is all right. Now you want to write KVL. So what do you do? Let me remove هذا. كله هنا. We'll put this. Minus plus وبنحط هنا هذا عشان to distinguish it باللون الأخضر أو this one. Let me لا هذا هنا. طيب هنا هذا minus R not R2 هذا R1 sorry هذا R1 okay R1 هذا R1 IA صح ولا لا؟ الآن أجي هنا I write the equation. الآن I'm going voltage rise صح ولا لا؟
صح.
So it's minus V1. هذا الآن صار voltage rise صح ولا لا؟
صح.
فيصير ايش؟ ماينس ايش؟ ماينس
R1.
بعدين تحط اللي انت القيمه اللي انت سويتها هذه ماينس R1 IA. طبعا اكمل انا على الR2 بس خلينا نشوف هذا ماينس مع ماينس شو يصير؟ بلس ايش؟ R1 IA صح؟
صح. يعني ما تفرق دائما.
ما تفرق بس ليش انا اقول خلها فولتج دراب؟ to avoid انك تحط الماينس ساين هنا، لانك لو ممكن تحط الماينس ساين لكنك في الكي في ال محتمل تنسى هذا الماينس فتطلع النتيجه ماينس في اي ماينس في 1 ماينس ار 1 اي اي which is wrong لانك انت you forget تحط على الكي في ال ماينس هذه صارت فولتج رايز. that's basically the idea behind it. Okay.
يعني always when doing a mesh the voltage across the resistor will be positive.
Yeah, not you make it a voltage drop. انت
Yes.
السؤال الان can I make it a voltage rise?
Yes but
Yes. بس you have to take care of the sign صح ولا لا؟
صح.
اوكي. انت دائما فكر فيها like this سواء KVA سواء mesh current whatever it is. اذا هذا الفولتج اللي هنا اذا الفولتج اللي هنا بلس ماينس 10 فولت طيب اقدر احط هذا ماينس بلس ماينس 10 فولت صح؟ ما يفرق isn't it؟
Yes.
Okay. طيب we continue الآن. Let's come now to another circuit which is now 3 mesh 1 and 2 and 3. The same thing we put اللي هو mesh current circulating, all of them is clockwise now. Okay, the same thing I make a drop if I wanted it on let's say on I1 I will make it drop. Okay, like what is shown here on this. So I'll come here, this is drop, this is drop, and this is drop. Okay, and then I express طبعا current that is going up on the same direction as I1. So this one will be R1 I1. Okay, والcurrent on the R3 هذا الR3 هذا الR3 طبعا drop. اوكي الكرنت هذا اللي هو الريزلتنت جاي بين I1 هذا جاي بين I1 هذا I1 وبتوين I1 and I2 I2. فمعناها هذا is going الcurrent اللي over here coming this way, it will be I1 minus I2. فمعناها الفولتج اللي هنا is going to equal to R3 I1 minus I2. Okay, and that's basically what will happen. So we will have, let's start over here. We will have R1 هذا we will have R1 I1. Okay, R1 I1. And then minus VS1 لأنها voltage rise. بعدين هنا قلنا plus، طبعا هذا دروب على ال VS3 فتصير plus VS3. بعدين على ال R3 تصير plus R3 of I1 minus I2. اوكي، بعدين نجي للR4 اللي هنا. اوكي، نجي للR4 اللي هنا. اوكي، and that is going to equal to, since I'm going down over here plus, فتطلع plus R4. طبعا الكرنت that is going down over here اللي هو I1 minus I3. طبعا this is equal to a 0. Okay, this is equal to a 0. طبعا I take this one اللي هو ال VS1, take it to the other side. Okay, take it to the other side and it will be VS1 minus VS3. Okay, and that's basically my equation. هذه, it's exactly this one. This is exactly this one, this equation. Okay, I do the same thing with mesh 2 and mesh 3, and I will have 3 equation, 3 unknown. Okay, 3 equation and 3 unknown. Okay, and then I go and simplify them. 3 equation, I simplify them. Okay, and then I put them in a matrix form. Okay, sorry, I put them in a matrix form. Like this. We notice that the matrix is a collection of resistor multiply in a vector of a current to give us a vector. طبعا multiply in a vector, unknown vector of a current to give us a vector of a collection of voltage. يعني هذا basically it's matrix forms of Ohm's law. Okay, of Ohm's law. This is the matrix form. Okay, طيب, let's look at a situation where we have a mesh, some of them clockwise, some of them counterclockwise. طبعا it will not affect. It will be exactly the same result. طبعا الفاليو حق المش كارنت حيختلفون لما انت assume all of them is clockwise and or you make it a combination. لكن if they have a current I هنا, it will not make a difference. Okay, it will not make a difference. Okay, طيب. Let's see. If I have, طبعا احنا we try to avoid. If you have a choice, avoid this. Why? لأنك you also can make a mistake. Let's try it. So we come over here to the first one, and we have اللي هو المش current coming like this, continue like circulating like this. Okay. So it will enter from on the 3 volt from the negative. So I will have over here, I can write it down over here, minus 3. Then I come to the 2 ohm over here. This is the 2 ohm. This is the 2 ohm. Okay. طبعا أنا I want, قلنا إحنا نبغاها voltage drop like this. Okay, voltage drop. طبعا what will happen? You have أنت you're flowing with the current I1 اللي هو this one. I want a different color. With this current. اللي هو هذا ايش؟ I1. Okay. But you also have I2 coming like this. هذا I2. Okay. That means the current that is entering on this direction is going to be what? I1 plus I2. I1 plus I2. That means the voltage drop on the 2 ohm is going to equal to 2 I1 minus I2. Okay, minus I2. طيب. Now I write that voltage drop as plus 2 I1 minus I2. Now I continue. I come to the 1 ohm, the same thing. هذا ال 1 ohm. Okay. هذا ال 1 ohm. we having هذا هو ال I1 coming like this. Will I3 now coming like this. هذا ال I3. If I put the polarity هنا plus minus voltage drop, I'm flowing with the mesh current I1. The current that is over here حيكون I1 minus I3. معناها ال voltage over here is going to be the voltage here is going to equal to one I1 minus I3. فهنا plus 1 I1 minus I3, and I close the parentheses. Okay, and that's basically the first equation over here, and that's exactly this one. Okay, look at the 3 هنا 3 طبعا equal to a 0. A 3 when it go to the other side become plus 3. Well, this is the 2 I1 over here. Well, this is the 1 I1 minus I3, which is this one. I apply the same procedure to the other two mesh, I2 and I3, and I get a total of 3 KVL equation. I simplify them. I put them in a matrix form. Okay, we notice that we said the matrix is a collection of resistor with a vector, unknown vector is a vector of unknown current, and the one on the right side is a combination of voltages. So basically this is matrix of a resistor times a vector of a current, give me a vector of a voltage. Well, this is basically Ohm's law on the matrix form. Okay, on the matrix form. Now I can solve and I get this. However, I look now, what do I want? I want I in this case is opposite to I1, right? هذا I1 coming like this. فمعناها I equal minus I1, okay? Or equal minus 69 over 11. Okay, 69 over 11. Okay. A question that arises sometimes is this. Which method? We already now saw that when we derive the mesh equation, we put them in a matrix form, but this is similar to the nodal analysis also. So if I have, this is the same problem as the previous one. If I have this problem, do I solve it using mesh analysis or I solve it using nodal analysis? Which one I use? What's the criteria? Well, let me show you. If I use the mesh analysis as the previous one, I need a 3 by 3 matrix, okay? Or you solve for 3 unknown. هذا حتكون matrix. فالdimensionality for it is a 3 by 3. Like this. Now, if I use the nodal analysis, I come and pick a reference over here. When you pick a reference, على طول هذا becoming by inspection is equal to 2 volt. I label the other one. So I will have is 2 unknown, VA and VB. So this, in order to solve, you will need only a dimension of 2 by 2. Two by 2. Okay? However, we can solve it on the nodal analysis and use the restrictions and the one by inspection. Okay? The restriction اللي هو على الفولتج سورس هذا. And then what we will find, we don't even need a matrix form. We can solve it by substitution, and I get the same result for I. Okay. طبعا in this case, nodal analysis is preferable over mesh analysis. Why? Because it has less computation. Now let's look at another example, okay, of mesh analysis. Suppose I have this. I have two meshes. In this case, I go and label them 1 and 2, and then in current had I1 and I2. Okay, and write KVL. Okay, and write KVL. For instance, I come over here on this one, and it will be هذا طبعا voltage rise. So I will write over here minus 15, and this one like this, and I can write it down as طبعا plus minus 5 I1 and I come over here on the 10 ohm, and it will be over here, it will be 10. طبعا the current is down, which is I1 minus I2. So this one will be 10 I1 minus I2 plus 10 I1 minus I2 وبعدين plus 10 okay, plus 10 لأن voltage drop is equal to 0. Okay, and then هذا هي, this is the same one. I simplify. I go and apply the same thing on the other one. Over here it will be also drop, and also this we said we'll make it a drop, even though the previous one is mesh one, but we said we don't want to. If you want to use this one, don't forget to put a minus sign when you do the KVL. Okay, so you will have a second equation on this اللي هو هذا هنا, this one. طبعا انت coming off from here, so this is minus 10 voltage drop, and then you come over here plus minus, will current this one اللي هو I2 minus I1, so the voltage is going to be 10 I2 minus I1. Okay, من ناحية ال 6 the same thing, it will be 6 I2, will 4 over here, also voltage drop, which is equal 4 I2. Okay, I simplify and I get this, so I get two equations to unknown. I'll be able to solve and see what do I need. Okay, now if you recall, when we studied the nodal analysis, we face a problem when we have a voltage source connected between non-reference and a reference. We couldn't express the current when we write KCL over here, okay? And we said this by inspection, if this is 10 volt, خلاص, this is equal to 10. We had this situation. And we have another situation, voltage source between two non-reference like this. Same thing, and we said we enclose it as a supernode. Well, we have something similar. Let's try this. We have this circuit over here. We have a current source on mesh 1, and then if we want to write KVL around this, we come over here طبعا. Let's say this one is 10 ampere. Let's start with the 1 ohm. So I'm going to put a voltage drop plus minus. طبعا the current that is entering over here is I1. Okay, so it's going to equal to 1 I1 1 I1. When we come to the 2 ohm resistor, also voltage drop like this, and I have the current coming down over here. This current coming down is a combination of I1 minus I2. Okay, so this one will be plus 2 I1 minus I2. Okay. Okay. Now, when I come to the 10 ampere, let's say there is a voltage here, plus V. And I can say plus V. That's okay. Sorry, minus V. You can put it plus minus. That's okay. So you say minus V equal to 0. The problem is I cannot express this voltage V in terms of the mesh current. There is no relation between the voltage across the current source and the current going through it or any other current. There is no relation at all for independent ideal current source. The same thing for the voltage source, the current going through it with the voltage across it. Now I cannot use this one as a mesh equation. Why? Then I am not able to express this one in terms of the mesh current. So it's a problem. Okay, it is a problem. So what's the solution? Well, the solution, I look at this direction of I1. I1 is going here up like this. That's I1. And I1 on here is exactly in the same direction as the 10 ampere. So I'll come over here and say then that I1 is equal to 10 by inspection. معناها now one of the unknown is known now اللي هو I1. That leaves us with only one current I2. I'll be able to go write single KVL in terms of I2, substituting I1 equal to 10, and I will be able to solve for I2. So then, if the current on the mesh, only one mesh, يعني الكرنت هذا does not belong to any other mesh, only this mesh, it's by inspection, whether up or down, we will be able to know what's the value. طيب, what if you have this situation? The current is between two mesh like this. Here I cannot come and say I1 is equal to 10 or I2 is equal to 10 or I1. It's not this. As a matter of fact, الريليشن بينهم اللي هو I2 minus I1 equal to 10. هذا الريليشن بينهم. That is the relation. That is the relation. Okay, I1 equal to 10. Okay. So what do? I cannot write KVL on mesh 1. I cannot write KVL I can, but I am not able to express the voltage اللي على current source. So what do? I go and enclose this one on what is called super mesh. In a similar situation, what we did with the voltage source, if you remember, we combined them to a super node. Next time, we will continue with this, okay? So let me stop the recording first.